Okay, hi people. Welcome back. This is the next one. Examples. So do take note. Okay, same thing we have to check. The range that we are asked to solve is from 0 to 2 pi, which means that this is in radian mode. Okay, so part A, I won't show you the steps, but I will give you the answer instead. You can go and try 3/4 pi and 7/4 pi. Okay. So I'll be solving maybe the part B. Okay. So part B and part A is about the same. And how come I choose to go through part B? Because some students may be confused. Okay, so part B, sine x equals to negative sine pi over 3. Take note, sine pi over 3 is our 60 degree. So which means that here is a clear indication I don't need to use calculator because it's 30, 60, 30, 45 or 60. So good. Then the next thing is that we need to know the angle that hyper is rotated is x. And this x here is the same as the question, the range. So we also don't need to create or change into a new range. These are things we have to check before we can proceed safely. Just like what I've told everyone is that when a patient go and see a doctor, okay, for the first time, go to a clinic, the clinic nurse or the clinic helper, they'll ask, do you have any drug allergy? So yeah, so same thing, they have to check. So with this, okay, I can happily write this as, okay, wait, give me a minute. Okay, this one will be in the, because here is a negative, so sine negative is the third and the fourth quadrant, ASTC. Okay, ASTC. Okay, third and the fourth quadrant. Do write down or have the habit write down. So over here, our basic angle, reminder, basic angle is always a cube. So will be alpha equals to sine inverse sine pi over 3. Okay, so which means that this is only pi over 3. So with that, we can proceed. So my x is equals to third quadrant, so it will be pi plus alpha. Fourth quadrant, 2 pi minus alpha. So this one will be my 4 over 3 pi, 5 over 3 pi. Okay. Part C, we have to be very careful with part C. Because why? You can see, okay, part C I do above. Okay, part C, the angle that hyper is rotated is half x. But the range given to us is x. So which means that this is a clear indication we need to create a new range. So be very mindful. So part C, okay, is that copy the question, cosine half x equals to 2/3. Okay, and from here I find basic angle first, as per usual. Some of the student, or every year there will be student asking me, so basic angle, finding basic angle, is it standard that we need to find? Yes, you need to find, because basic angle part, okay, by attempting to find basic angle, 1 mark is being awarded, so you need to be mindful. So basic angle alpha equals to cosine inverse 2/3. Okay, this one we can't say don't use a calculator. Why? Because when you cosine inverse 2/3, the angle is not 30, 45 or 60, so we now have to change our calculator to radian mode, which we have showcased to everyone. Then from here, okay, then we have to be mindful. The range given to us is from 0 to 2 pi, but now we are finding for half x, so the range will change to just 0 to pi, which means that, okay, the hypo actually only rotate 2 quadrant. So that one we need to be very, 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 very mindful. So with that, half x equals to, because this part cosine positive is in our first and fourth quadrant, but because the range over here only rotate 2 quadrants, right? There's only one answer. We won't go to the fourth quadrant, so we need to be very mindful. That's why the range here is really to guide us how many answers to provide. So with this, half x equals to alpha, which is the first quadrant. Okay, the fourth quadrant we can don't write because we know that there's only rotate the second quadrant. So with this will be equals to my alpha. Okay, half x equals to alpha, so my x equals to 2 alpha, which is you can multiply with this answer, which I will be saving in my calculator. So it'll be answer not exact 3SF. Okay. So far all the examples that I've went through, you can, if you didn't realize, I classified them as linear Trigo equation or one term Trigo equation. Now we'll advance to multiple terms Trigo equation. What do I mean by that? Take a look. Okay, next one. Okay, this is the type of questions that during assessment we already test. So over here, this is very similar to, for example, maybe 2x squared equals to square root 3x, then maybe y, for example. Then if we are solving this, okay, I know cannot be solved, but I'm just showing you relevant examples. So this one will be, I factorize out the x, then I have 2x minus square root 3y in this manner. Then we solve each of the bracket equals to 0 separately. And we are applying this because this is from your lower side math. So with this, okay, let's take a look. Okay, the rest will be applying our Trigo solving knowledge. So with this, okay, let's copy question. 2 sine square x equals to square root 3 sine x cosine x. Do take note, over the years, there are students who will cancel out the x. So that meant by that, this is wrong. Okay, this is wrong, even for the algebra part. So some student for here, this is wrong one. Student will do this 2x squared equals to square root 3 xy. Then they say, oh, I divide by x on both sides. So become 2x equals to square root 3y. This is wrong. Why? We can divide by numbers on both sides of equation. We can times number on both sides of the equation. Numbers, but we cannot divide or times variable on both sides. Okay? So we need to be very, very, very mindful about this. Okay? So with this, and take note because this one is sine square x, so it's considered like a quadratic equation. So quadratic equation, if you want to solve, we have to make sure it's equals to 0. So it'll be 2 sine square x minus square root 3 sine x cos x equals to 0. Then you can see that there's a common term, which is a sine x. Okay, so with this, we factorize out any common Trigo term. So I have sine x, 2 sine x minus square root 3 cosine x equals to 0. Okay, so you can see this is like our solving quadratic equation like that, whereby we have now 2 brackets. So each of the bracket will be equals to 0. Then from there, we'll be applying those knowledge that I've shown you all in the previous example, our Trigo equation solving. So with this, something new to introduce in a while. So sine x equals to 0, or 2 sine x minus square root 3 cosine x equals to 0. Do take note, when a Trigo equation is equals to 0, minus 1, or 1, okay, we won't be finding the basic angle. Why? Because the hypo in such case will be between two quadrant. What do I mean by that? For example, okay, if I use sine graph is like that. Okay, 1 to -1. When sine x is equals to 0, 0 are all these points here. Okay, so if all this point is the hypo is on this line, okay, then this point the hypo is at where? 180 degree. So the hypo is here, and for this point, the hypo is, for this point the hypo is 360. The hypo is at here. So because there is no basic angle, okay, because the angle that hypo forms with the horizontal line is always 0, so no point finding the basic angle. So under such case, when the Trigo equation is equals to 0, -1, 0 and 1, we have to use Trigo graph, the respective Trigo graph. So this is sine graph. So my x, sorry, shouldn't be red. So my x equals to 0, pi, 2 pi. Take note, question is in radian. Then after that, how about the next one? 2 sine x minus square root 3 cosine x. So for this, okay, 2 sine x, because now these are all linear already. So, and here it contains two trigo identities, sine and cosine, which we cannot proceed, because when we are solving trigo equation, it must be all sine, cosine, or tangent. There cannot be a mix. So with that, we have to change all the sine and cosine into one trigo identity. So what do we do? Let's take a look. Okay, 2 sine x equals to square root 3 cosine x. Do take note, we know identity tangent equals to sine over cosine, so we'll be using that. So I bring all the trigo term together. So sine x over cosine x equals to square root 3 over 2. So here tangent x equals to square root 3 over 2. So with this, now I have tangent x, only a single one. So tangent x is positive. So positive will be first and third quadrant, ASTC. So first and third equals positive. Then from here, we find basic angle. So basic angle alpha will be equals to tangent inverse square root 3 over 2. And happen that here is not the special angle, so we really have to change our calculator to radian mode. So first quadrant, x equals to alpha. Third quadrant, x, pi plus x. Pi plus alpha. So with this, 0.714, answer not exact, trace F, 3.86. Okay, so this marks the part 2 of Trigo equation solving. Do watch this part 2 again if you encounter any difficulty. Okay, and get ready for part 3 of Trigo equation solving, which is the final segment. Thank you.